All right, in this video, we are going to do a crash course on all things linear. So this is a linear review, starting with slope. Slope is denoted by the letter M. It is also called the rate of change. And it's a value that describes the steepness of a line. And then the formula, which you may remember from Algebra 1, is rise over run. And what that means is you are measuring your vertical distance, the change in y over the change in x. So if you have 2 points, you subtract the y's and then divide it by subtracting the x's. And this is sometimes denoted with a delta y over delta x, and that delta, that triangle, just means change in. Okay, and so if we want to calculate the slope between these 2 points, I like to label them x1 and y1, x2 and y2. And so the formula says y2 minus y1 over x2 minus x1. Okay, and so y2 is -7 minus y1, which is -5. And then x2 is 4 minus, the minus is part of the formula, -4. Okay, and so be careful, there's minuses in the formula, subtraction signs, and then we're subtracting negative coordinates. Whenever you see 2 negatives, minus negative, that's the same as positive, and so it's easier if you rewrite it as -7 plus 5, 4 plus 4. Okay, not because it's a plus in the formula, it's because 2 negatives right next to each other make a positive. Okay, and so that gives us -2 over 8, and then always simplify your fractions. And so our final answer would be -1/4 for the slope. Okay, the next thing we need to review is the y-intercept, which is often denoted with the letter B. And in situations or real-world problems, it's the initial value when time is 0. It's where it crosses the x-axis. Okay, and so in Algebra 1, you learned 3 different forms of writing a linear equation that you will likely use in all of your future math courses. Slope-intercept form is the most famous, y equals mx plus b. Point-slope form is used a lot, especially when you get to calculus. And then standard form. Okay, and so in y-intercept form, you are given the slope, which is m, and the y-intercept, which is b. Okay, that's the easiest to graph from. Point slope is useful when you have the slope still. This m is still your slope. But this x1, y1, this is any point on the line. Any point. So it's nice when you don't have the y-intercept and just have any point on the line, x1, y1. And then standard form is often where we start when we're writing equations from situations, but you don't really get any information for free. A is just a number, B is just a number, C is just a number. Those aren't your intercepts, they're not your slope, and so you don't get any free information from standard form. Okay, and so for these next few examples, we're going to write the equation of the line in each form. And so depending on what we're given, that determines where we're starting. And so here we are given the slope is 1/2, and it passes the point 0, -5. Well, we recognize that as our y-intercept, and so that means our b value is -5. Anytime this is 0, this means that this point is our y-intercept. Anytime x is 0. And so we can immediately jump to slope-intercept form. which would be mx plus b, so y equals 1/2 x plus b would be minus 5 since it's negative. Okay, if instead we are using point slope form, I always set it up as y minus the y coordinate equals m parentheses x minus the x coordinate. That's how we set it up in Algebra 1. You are filling in the y with the y coordinate and the x with the x coordinate. And so I leave blanks for that. Okay, and so we know m already is 1/2. And the point we're given, x1, y1, the x is 0 and the y is negative 5. And so now all we have to do is simplify this. Minus negative becomes a plus. And minus 0 is just x by itself. And so that's how you would see it written. And then if you wrote the minus 0, it wouldn't be wrong. It's just not fully simplified. Okay, and so that's our point slope form. And then lastly, we need standard form. Okay, and so to convert to standard form, we don't usually do that, but it's worth doing for when we get to systems, is I start with slope-intercept form. Okay, and so for standard form, x and y are together on the left side of your equation, and the constant is to the right. Okay, and so the first thing I'm going to do is move the x term to join the y. And when you move the x term, it changes sign. So now it's negative 1/2 x plus y. And then we have the equal sign minus 5. So basically subtracting 1/2 x from both sides. Okay, and so from there, we want a, b, and c. We want a for sure to be a positive integer. And then we want b and c to, we want b and c to be integers as well, positive or negative. We just want a to be positive. And so if you see a fraction, which we do, you are going to scale the entire equation by that denominator. So in this case, the denominator is 2, and so we are going to scale the entire equation by 2 so that we can clear the denominator. There's also a negative in front of the x, and so we want to put a negative to cancel that out. Okay, and so negative 2 times negative 1/2 would be 1, and so we're just going to write the x. Negative 2 times y is negative 2y, and then negative 2 times negative 5 is 10. And so the final standard form would be x minus 2y equals 10. Okay, so for this next example, we have a slope of negative 3 and a random point on the line x1, y1. So this time we have to start with point slope form. We don't have the y-intercept for free. Okay, and so y minus the y equals m x minus the x. And so the x is negative 2, the y is 13, and so now let's simplify. Y minus 13 equals negative 3. I see a minus negative, so that's going to be a plus 2. So when you're given a point slope form and you're trying to identify which coordinate you have, you're going to take the opposites of what you see. And so if I see a plus 1 and a minus 13 in this equation, I know my coordinates are going to be the opposite of that, negative 2, positive 13. Okay, and so to get to slope-intercept form, we just have to rearrange this equation. And so our first step would be to move the 13 to the other side. Well, actually, let's wait. When you see slope-intercept form, there's no parentheses, and y is by itself. And so our first step is go ahead and leave the left side alone, but distribute your slope to the parentheses so that we don't have the parentheses anymore. So that would leave us with negative 3x minus 3. So first step is distribute, and then your last step is to add whatever is with the y to the other side. It only combines with the constant term. Negative 3 plus 13 is 10. So there's our mx plus b, our slope-intercept form. Okay, and so to get to standard form, I start with slope-intercept form and move the x to the other side. So now it's positive 3x. And we just have 10 on the right now. And this is a positive integer, and I don't have any fractions. And so after moving the x term, we're done. Okay, on this next example, we're just given 2 points. We're not given the slope. And so we need to find the slope first. And so that's where we're going to use this formula and use what we did up here, y2 minus y1 over x2 minus x1. Okay, and so here's my x1, y1, x2, y2. And so my slope is y2 minus y1 over x2 minus x1. So in Algebra 1, I make them do their fraction bar and do their minus signs so they don't lose the minus signs in the formula, especially when you're dealing with negatives. Okay, and so y2 is negative 3, y1 is 9, x2 is 6, x1 is negative 2. Okay, and so I have a negative 3 minus 9 on top, and then a 6 plus 2, seeing that minus negative. And so I'm left with negative 12 on top and an 8 on bottom. Both of those are divisible by 4, so negative 3 halves. You want the simplest form for your slope. Okay, and so now that we have our slope, we can use either point. I think I'm going to go ahead and use the x1, y1 to do our point slope form. Okay, so it's y minus the y equals m, which we just found, parentheses x minus the x. Using x1, y1, my x is negative 2, my y is 9. And so y minus 9 is on the left, negative 3 halves, and then x minus negative 2 is x plus 2. There's our point slope form. To get to slope intercept form, first distribute the negative 3 halves. So we have y minus 9 equals negative 3 halves x. And then negative 3 halves times 2 is negative 6 over 2, which is negative 3. The 2's cancel. Last step, we are going to add 9 to both sides. So negative 3 halves x plus 6. Lastly, we need standard form. And so first step, move the x to the other side. So now it's positive 3 halves x plus the y, and we just have a 6 on the right. And then I see a 2 in the denominator, so we are going to scale the whole thing by 2. We don't need a negative because the x term is already positive. So distribute the 2, and we get just a 3x. 2 times 3 halves is 6 halves, which is 3. The 2's cancel. 2 times y is 2y, and 2 times 6 is 12. Okay, last one here. We have an x-intercept, which is 15, 0. The x-intercept is an x value when y is 0, and a y-intercept of negative 6. So write them as ordered pairs because that's how you're going to find the slope. You need an x1, y1, and an x2, y2. Okay, and so to find the slope, y2 minus y1 over x2 minus x1. Fraction bar, minus signs. y2 is negative 6, y1 is 0, x2 is 10, x1 is 15. So we get a negative 6 on top. 10 minus 15 is negative 5. A negative on top and bottom cancels out, and so our final answer would be 6/5. Okay, so now that we have the slope and the y-intercept, that's our b value, we can go straight to slope-intercept form. Y equals mx plus b would be plus -6, so just -6. For point-slope form, you could use either the y-intercept or the x-intercept. I'm going to use the x-intercept as my x1, y1. Okay, and so it's y minus the y equals m, which we know is 6/5, parentheses x minus the x. Okay, and so our x-coordinate is 15 when our y-coordinate is 0. Simplify that, we get y equals 6/5 x minus 15. For point-slope form, we leave parentheses, so don't distribute. You'd get right back to slope-intercept form. The only time you get rid of the parentheses is if you have a -0 situation. All right, last, we get standard form. I'm going to start with slope-intercept form, move the x to join the y, so now it's -6/5 x plus the y equals -6. Just taking this x term and putting it on the other side. And then we need to scale this equation by a negative and a 5. Okay, and so -5 times -6 is 30 over 5, which is just 6. The 5's cancel, and it becomes positive, just like we wanted. -5 times y is -5y, and -5 times -6 is positive 30. Next, we're going to talk about parallel and perpendicular lines. Lines are parallel if and only if. When you see two f's, that means if and only if their slopes are the same and their y-intercepts are different. If their slopes are the same and their y-intercepts are the same, it's the same line. So it's important that their y-intercepts are different. Okay? And then linear or lines are perpendicular if and only if their slopes are opposite reciprocals. Okay? And so that means flip the fraction that's reciprocal and switch the sign. So if it's positive, it becomes negative, and vice versa. You'll hear me say flip it and switch it. Flip the fraction, switch the sign. Okay, so for each description, write the equation of the line in standard form. Okay, and so standard form is ax plus by equals c. So that's our goal. Okay, so we need to be parallel to this line. Okay, and so in order to be parallel, we need to find the slope of this line. It's currently in standard form, and so in order to find the slope, we need to convert it to slope-intercept form. So to do that, you are going to move the x back to the other side, and it's going to become -5x. And so I get -3y equals, put the x term first, followed by the constant, which is +18, and then divide every number by -3. Okay, and then simplify. -5 over -3 is +5/3, and 18 over -3 is -6. We don't really care about that value. We care about the 5/3. That's our slope. Okay, and so we know the slope of the original line is 5/3. Okay, and so parallel will also have a slope of 5/3. And so once we have the slope of 5/3 and we have a point, that gives us an x1 and a y1. x1 is 9 and y1 is -3. And so we're going to use point slope form. Okay, so y minus the y equals m, which we know is 5/3, x minus the x. We fill in the 9 for the x, -3 for the y. So that's y plus 3 equals 5/3 x minus 9. Okay, so there's our equation. The annoying part is we need standard form. Okay, and so to get standard form, first we need to distribute the 5/3, which would give me 5/3 x. 5 times 9 is 45 over 3, which is 15. When you're multiplying a fraction by a whole number, multiply by the 5, divide by the 3. The bottom number is what you're dividing by. Okay, and then we need to subtract 3 from both sides. So there's our slope-intercept form. Still not what they wanted. They wanted standard form. And so we move the x term to join the y. And then lastly, we scale it so that we only have a positive integer here. So we need to scale it by a -3. All terms. So -3 times -5 is 15 over 3 is 5 for the x. -3 times y is -3y. -3 times -18 is positive 40 or positive 54. Okay, and so our final answer is 5x minus 3y equals 54. Now there is a shortcut to everything I just did. Okay, if you are parallel to something in standard form, notice there's a 5x minus 3y. A parallel equation will also have a 5x minus 3y. And so go ahead and write your 5x minus 3y. And then we don't know what it equals, but they give us an x and a y to plug in. So you would plug in this 9 for x and -3 for the y. So 5x minus 3y, plugging in the 9 and -3 would give me 45 plus 9, which is 54. So that's how you're going to get the constant. Okay, and so the shortcut for parallel is copy what you see and then plug in the given point to figure out what the number is. That's if they want standard form. Okay, so for this next one, they want perpendicular to this given line. The only thing we care about for the given line is the slope, which we get for free because they're giving us point slope form. So the original slope is 2/3. To get perpendicular, we flip the fraction, switch the sign. So our new slope is -3/2. And then luckily they gave us the y-intercept. And so we can skip to slope-intercept form, which would be y equals the slope -3/2 x plus b would be -12. And then to get to standard form, we would move the -3/2 to the other side. So it's 3/2 x plus the y equals -12. And then we just need to scale the entire equation by 2 to get 3x plus 2y equals negative 24. As long as this is positive, you're good. So that would be our final answer. All right, lastly, we need to review how to graph lines. And so it's easiest to graph from slope-intercept form or point-slope form. And so let's start with this first one. First, I'm going to rewrite it so that the x term is first, and then the constant is last, keeping the fact that this is positive and this is negative. Don't change anybody's sign. And so I can see that my slope is negative 1/6. And my y-intercept is 5. Okay, so start at your y-intercept, which is 5. And then this top number is your rise. And then the bottom number is your run. And so if you have a negative slope, just move the negative to the top. You can move it to the top or bottom, just don't put it on both. It's only one or the other. So if my rise is negative, that means I'm going down 1. And then my run is positive, so I'm going right 6. Down 1, right 6 to get my other points. So down 1, right 6. 2, 3, 4, 5, 6. There's another point on my line. If you instead viewed the one on the negative on the bottom, this would be up 1, left 6. So we could go up 1, back 6. 2, 3, 4, 5, 6. All of these points lie on the same line. And so whenever you have a negative slope, it should be a decreasing function as you go from left to right. Meaning if you were traveling from left to right, you're going down the mountain, decreasing. Okay, for this next one, it's point slope form. And so we get the slope for free. And then we get a point for free. Here I see a -1, so that means my x-coordinate is 1. And then I see a +8. That means my y-coordinate was -8. Take the opposite of what you're seeing from this equation, because in point slope form, it's minuses. If I go back to the original, these minuses, read them as opposites. Okay, and so we can start by graphing that 1, -8. And then we can use our slope, which means we're going to rise 5 and run 4. Rise means up because it's positive, and run means right because it's positive. So rise 5, 1, 2, 3, 4, 5. Run 4, 1, 2, 3, 4. And then we can fit another point. 1, 2, 3, 4, 5. Run 1, 2, 3, 4. It's a good habit to graph as many points that fit on your line. The more accurate, the better. Okay, next we have standard form, which isn't that useful for graphing. And so the strategy we use in Algebra 1 is to convert to slope-intercept form. And so we're going to move the x to the other side, which would become -4x. And so that leaves us with a -3y equals -4x right at first, followed by the 6 plus 6, and then divide every number by the -3. Okay, so that leaves me with y equals +4/3 when I simplify the negative over negative. And then 6 over -3 is -2. Okay, and so that gives me my y-intercept of -2, a slope of 4/3. Start at the y-intercept of -2. And then we are going to rise 4, run 3. Up 4, right 3. Up 4. 1, 2, 3, 4. Right 3. Up 4. Right 3. Up 4. Right 3. We could go down 4 and back 3 and still fall on the line. And there's our line. Okay, last one, still in standard form, so move the x to the other side. leaving me with 2y equals, write the x followed by the constant. And then if you want to fill in a 1 here, whenever it's just a negative or just an x, there's technically a 1 there. And so that way, when we divide every number by 2, you can see what you're dividing. Okay, so that gives me y equals negative 1/2 x, and then negative 6 over 2 is negative 3. So my y-intercept is negative 3. My slope is negative 1/2. And so move the negative to the top. That means our rise is down 1, and our run is still right 2. Okay, so start at negative 3, our y-intercept. And then we are going to go down 1, right 2. Down 1, right 2. Notice it's a decreasing function as I keep going down 1, right 2. And then if we want to go up 1, we would have to go back 2. Up 1, back 2. As long as you count for negative in either the down direction or the left direction, you're going to end up with your negative slope, your decreasing line.